Hey everyone, welcome to our first of 3 videos about cell membrane transport. So how materials are moving across the cell membrane. All right, let's first review about solutions. We talked about this when we talked about properties of water. But with solutions, there's something called the solute. And that is the substance that is being dissolved into a solvent. So good examples of a solute would be sugar or salt. Solvent is the substance that does the dissolving. So, a really good example of a solvent is water. Water is actually the universal solvent. So, solute is what you add, like sugar or salt, and solvent is the liquid that does the dissolving, such as water. What is concentration? So we know different liquids have different concentrations of their solute. So basically, we could calculate the concentration by doing the mass of the solute divided by the volume of this whole solution and get the concentration. So you can see over here in this area, there's a low concentration. There's a kind of a small number of particles or solutes. And down here, there's a much higher concentration. You can see there are many more particles of the solute. Concentration is almost kind of like saying the density, but it's the mass of the solute divided by the volume of the solution. All right, now once you know that we have things called concentrations, you can find out that we have this thing called a concentration gradient. Now, a concentration gradient is a gradual change in the concentration of solutes when there are two different regions in a solution. And basically, it's an uneven distribution of particles across the cell membrane when we're talking about cell membrane. So, you can see here there's a high concentration in this area. There's a lot of particles, and there's a low concentration over here. So there is a concentration gradient. There's an uneven distribution of particles, and there's a gradual change, high and low. All right, so what does that all mean? Well, what we're going to be talking about is transport of materials across the cell membrane. And we talk about passive transport and active transport. For passive transport, it's when materials move from an area where there's high concentration to an area where there's low concentration. And we say that's with the concentration gradient, and it doesn't require any extra energy. Some examples are diffusion, osmosis, and facilitated diffusion. So with passive transport, we say the materials go high to low, they go with the flow, it's passive transport. High to low indicates that it's going from high concentration to low. So if you see here, high concentration going to a lower concentration. And that is what we call with the concentration gradient when it goes high to low. It's kind of like at the end of the school day, if you're walking downstairs with everybody else, you're going with the flow of traffic. You're going from an area of high concentration upstairs to an area of low concentration downstairs. You're kind of doing passive transport. Now, active transport is from low to high, and it's seen here, low concentration, very few particles of solute, high concentration of solute down here, a lot more particles. So we're going from a low concentration to a high concentration. That's moving against the concentration gradient, and it does require ATP energy. And we'll learn more about ATP later, but it does require energy. Examples include active molecular transport, endocytosis, and exocytosis. But you can remember active transport, low to high, go against the tide, is active transport. And it's kind of like if you had gotten all the way downstairs at the end of the day and you realize, oh my gosh, I left my Chromebook upstairs. And you're coming back up the stairs against the flow of traffic. It's kind of hard and it requires a lot more energy. You're going from low concentration to high concentration. That would be kind of like active transport. All right, our first example of passive transport is called diffusion. And diffusion is a process where molecules tend to move from an area where they're more concentrated to an area where they're less concentrated. And this process does not require energy. So, diffusion across the cell membrane, you can see here area of high concentration, area of low concentration, and materials are going to move from high too low, they're going with the flow. It's passive transport. And in this case, it's diffusion because it's the movement of different molecules of solute. So you can see they will diffuse until they're more evenly distributed. You could see that in a beaker, and if you're hybrid, we'll actually do this in class. But coloring dye, food coloring, will move if you put it in a beaker from an area of high concentration, and it will spread out throughout the beaker until it reaches what we call equilibrium. Let's talk about that. Equilibrium occurs when the concentration of the solute is the same throughout the system. So there is an even number of particles outside of the cell membrane as there are inside of the cell membrane, and that would be at equilibrium. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 molecules of solute, and down below on the other side of the cell membrane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal number of molecules inside and outside. And that doesn't mean that the molecules will stop moving altogether. They have kinetic energy, but it just means that for every one that moves out, another one will move in. And so that's to make the concentration the same inside and outside. And that happens through the process of diffusion. Thank you so much for listening.